This is problem 3-123. It's on page 159. A 20 cubic meter tank contains nitrogen at 23 degrees Celsius, 600 kilopascals. Some nitrogen is allowed to escape until the pressure in the tank drops to 400 kilopascals. If the temperature at this point is 20 degrees Celsius, determine the amount of nitrogen that has escaped. Okay, so we've got two states here. We've got 3-123. We've got the initial state, and of course the volume of the tank is constant, that's 20 cubic meters. It is nitrogen, initial temperature 23 degrees Celsius. Since nitrogen is most likely going to behave as an ideal gas, we'll go ahead and convert that to Kelvin. We'll have to do that in any case. The pressure is 600 kilopascals. Now, of course, what's going to happen when the gas is released is that the pressure is going to decrease. The other thing that's going to happen is the temperature will go down. This may seem counterintuitive initially, but we'll talk later in the course about why that is. Anyway, both the pressure and the temperature will go down. And finally, the pressure in state 2 is 400 kilopascals, and the temperature is 20 degrees Celsius, which is 293 Kelvin. Now, a schematic of the system is just a tank of nitrogen. Move that over there. That either has a leak in it, or for whatever reason, the nitrogen escapes. Some nitrogen escapes out of it. And we're supposed to find the amount of mass that has escaped. Now, we could find the mass in the system initially because we know the volume. We know the temperature, we know the pressure. So the mass in the tank initially is PV over RT. So just rearranging the ideal gas law. I don't need a 1 for the volume because the volume remains constant. Anyway, plugging in the numbers, 600 kilopascals for the initial pressure, volume of 20 cubic meters, gas constant for nitrogen, I looked that up, it's 0.2968 kilojoules per kilogram per Kelvin, and the initial temperature, 296 Kelvin. Let's see, kilopascals, cubic meters cancels with kilojoules, so we just got kilograms, so that works out. And the amount of mass is 136.59 kilograms. So that's the mass in the system initially. Well, wait a second, the volume in state 2 is the same, so couldn't we do this? Couldn't we use the pressure and temperature in state 2 as well as the volume in state 2 to find out how much mass there is in state 2? And in fact, if we want to know how much mass escapes, it would just be the initial mass less the final mass, right? Think about it in terms of a bucket of water. You have 10 gallons of water, you pour out 2 gallons, and the difference is 8 gallons. So the 10 minus the 8 is the 2 gallons that escape. Of course, we're talking about mass in this case, not volume, but you get the idea. It's the same principle. So the mass in state 2 would be the pressure in state 2, volume R T2. And so, of course, it's the same game as before, except now the particular values have changed. Still 20 cubic meters, that's the volume taken up by the nitrogen. It's less concentrated, but that's okay. 2968, gas constant hasn't changed. And the temperature did decrease, it's 293 Kelvin. Same unit situation. We'll end up with kilograms of mass. This comes out to about 91.99 kilograms. And so the amount of mass that escapes is the initial 136.59 less 91.99. I haven't put in the units because they're the same. But anyway, that comes out to 44.66 kilograms of mass that has escaped from the system.